Okay, so imagine this. You send a message in a bottle, but not across an ocean.
Yeah, more like into the vast, dark, cosmic sea, right?
Yeah.
A tiny piece of us just heading out there.
Exactly, an almost eternal journey. And that's the incredible story we're diving into today.
We're doing a deep dive into the Pioneer program, focusing really on the Pathfinder, Pioneer 10.
We've got a great set of sources here covering, the tech specs, the big mission moments.
The famous message it carried, the plaque, and where it is now. Basically, its whole life story and beyond.
Right. And our mission today is to pull out the most fascinating bits from all this. What really made Pioneer 10 so groundbreaking?
What did we learn from it? And maybe what does its journey, its legacy as our first, physical thing sent beyond the solar system, what does it mean?
Okay, so to really get Pioneer 10, we probably need to understand the program it came from first, yeah.
Absolutely. The Pioneer program. This was NASA's big initiative for exploring the solar system, and they were really pushing the envelope technology-wise for deep space missions back then.
Right, things like spin stabilization. That was one of their things.
Exactly. Spinning the spacecraft to keep it stable, kind of like a gyroscope. Much simpler than complex thruster systems for orientation. And using RTG's radioisotope thermoelectric generator.
Nuclear batteries, essential kit if you're going where the sun don't shine, basically.
Pretty much, yeah. Solar panels just wouldn't cut it out past Mars, really. And while Pioneer 10 and 11 are the famous ones, the whole program actually involved 8 different spacecraft projects, all managed by NASA Ames.
8. Wow. So before 10 and 11 headed out to Jupiter and Saturn?
Yeah, there were earlier Pioneers, numbers 6 through 9, plus missions to Venus. They stayed, within the main solar system, but they were vital.
How so?
Well, they studied the sun, solar wind, cosmic rays, basically testing the waters and proving the tech worked. Pioneer 6 launched way back in 65.
65.
Yeah, it's one of NASA's oldest. They were still getting signals from it in the mid-90s. Just incredible longevity.
That's amazing.
And then there's the kind of interesting story of Pioneer 12, Pioneer H as it was planned.
Pioneer H?
Yeah, it was built, designed as a third deep space probe to follow 10 and 11. But NASA management canceled it.
Seriously. Built and then canceled. Where is it now?
Ended up in museums. But the planning wasn't wasted. Its intended flight path and some of the design work actually influenced later missions.
Like what?
Like Ulysses, the one that studied the sun's poles. And even some aspects connect to the Juno mission at Jupiter today, especially with magnetometer readings, so it had a sort of echo.
Huh. So even the mission that never flew left its mark.
It did. And the whole Pioneer program overall, it massively boosted confidence in doing these long, tricky, deep space flights. And the data, the information we got back about Jupiter and Saturn, it basically rewrote the textbooks for years.
Okay, but let's zero in on the main event for us today. The one everyone remembers.
Yeah.
Pioneer 10. Originally Pioneer F, right?
That's the one. Launched March 3rd, 1972, Cape Canaveral. On an Atlas Centaur rocket. Built by TRW, weighed about 258 kilos at launch.
Empowered by those RTGs you mentioned. 4 of them?
4 of them, yeah. Giving about 155 watts initially, and they were mounted out on booms.
Right, to keep the radiation away from the sensitive science instruments. Smart.
Absolutely necessary. And the design itself is pretty iconic, isn't it? That hexagonal body.
Yeah, and the big dish antenna on top. 2.74 meters across. For talking back to Earth.
And kept stable by spinning. Simple, elegant design, really.
So it's a journey.
Yeah.
It's like a highlight reel of firsts. What was the first big challenge?
The asteroid belt.
Yeah.
Definitely. Before Pioneer 10, people weren't even sure if you could fly a spacecraft through it safely.
Because it's full of, asteroids.
Yeah, rocks, dust, dwarf planets, millions of objects whipping around between Mars and Jupiter. There's a real fear of collision, so just getting through was a huge milestone.
And Pioneer 10 did it. First one through. July 72 to Sep 73.
And it didn't just survive, it took measurements, figured out the belt wasn't quite as dense or dangerous as some feared. That basically paved the way for all the missions to the outer planets that followed. Voyager, Galileo, Cassini.
A true pathfinder, like you said.
Oh,
Okay,
wow.
so after the belt, Jupiter.
Jupiter, December 3rd, 1973, first spacecraft ever to reach it.
And the stuff it found there, just mind-blowing for the time, wasn't it?
Oh, completely. It gave us our first proper look at those intense radiation belts. Much stronger than anyone guessed.
Ouch. Bad news for unshielded astronauts, then.
Definitely. It mapped Jupiter's huge magnetic field, confirmed the planet is mostly liquid hydrogen under the clouds.
The liquid planet. Wild.
Took atmospheric measurements, got photos, started taking pics from 25 million kilometers out, sent back about 500 images in total.
How close did it get?
Closest approach was about 132,000 kilometers. Pretty cliché, relatively speaking.
So Jupiter flyby done, dude. Just keep going.
Just kept going on its way out,
Yeah.
and it kept ticking off milestones. First human object passed Neptune's orbit. That was June 83.
Past Pluto's orbit that same year too, didn't it?
Yep. And that crossing in 1983 is generally marked as the moment it effectively left the sort of known solar system, became our first interstellar traveler.
Which leads us right to maybe the most famous part, the plaque.
Ah, yes, the message. Carried by both Pioneer 10 and 11. The gold anodized aluminum plaques.
Designed as a greeting card to any ETs who might stumble across it like millions of years down the road.
That was the idea. Very hopeful, very ambitious. Carl Sagan and Linda Saltzman were the key figures behind it.
Sagan, the astronomer, and Saltzman, the artist. And the plaque itself, 15 by 23 centimeters.
About that size, yeah. Gold anodized aluminum, meant to last for eons, mounted on the antenna struts, kind of sheltered but visible.
Okay, so what's actually on the plaque? Break it down for us.
Right, so first, there's a diagram of a hydrogen atom undergoing a specific energy transition. Hydrogen's the most common thing in the universe, so the idea was this could be a universal yardstick for time and length.
Okay, a fundamental constant. Makes sense. What else?
Then there's the pulsar map. This is really clever. It shows the sun's position relative to 14 known pulsars.
Pulsars being those spinning neutron stars giving off regular radio pulses.
Exactly. The lines point to the pulsars, the length shows relative distance, and binary code along the lines gives the pulse periods at the time of launch. Since pulsars slow down over time, any civilization finding it could work out when it was launched by comparing the plaque's periods to their current observations.
Wow, okay, that's like a cosmic timestamp and address label rolled into one.
Pretty much. Then there's a simple diagram showing the solar system, Earth as the third planet, and Pioneer's trajectory launching from Earth and swinging by Jupiter.
A little note here, though. Pioneer 11's trajectory changed later, right? It went to Saturn.
That's right. So the trajectory line on Pioneer 11's plaque isn't quite accurate for its final pass. A small detail, but interesting.
And then, the bit that caused all the fuss. The pictures of us.
The human figures, a man and a woman shown standing, and yeah, they definitely sparked some debate back on Earth.
What kind of reactions are we talking about?
Oh, all sorts. Our sources mention feedback from military folks, feminists, artists, religious groups, a real mix.
Why were they drawn separately? Sagan explained that, didn't he?
Yeah, he worried if they were holding hands or something, an alien might interpret them as one single weird-looking creature. He wanted to show two distinct individuals.
Okay, I can see the logic.
Right.
And the artist, Linda Saltzman.
She drew inspiration from classical art like Da Vinci and Greek sculptures. But apparently she didn't really anticipate the negative reactions some people had.
Criticisms about? What specifically?
Well, their posture, the fact they were nude, that was a big one.
Right. Too explicit for space.
Some thought so. Others objected to the man's raised hand. Was it a greeting? Too aggressive. Some apparently suggested a prayer pose might be better. It just shows how hard it is to represent humanity universally, even to ourselves.
It really does. Such a simple drawing,
Yeah.
yet it touches on so many complex human issues. Culture, religion, representation.
Yeah. And it's interesting to contrast it with the Voyager Golden records launched a few years later.
How are they different?
Much more comprehensive. They had sounds, music, images, greetings in different languages, a richer picture of Earth. But notably, they didn't include anatomical drawings of humans like the Pioneer plaque did, maybe a reaction to the earlier controversy, or just a different approach. More technical, maybe.
And perhaps more hope that Voyager might actually be found someday, being more advanced probes?
Possibly. Voyager 1 is currently the farthest human-made object, so maybe.
Okay, so Pioneer 10 flies past Jupiter, carries this debated message out into the void. What happened next? The mission didn't just stop there, did it?
No, not at all. The official mission formally ended on March 31st, 1997.
And how far out was it by then?
About 67 astronomical units, so 67 times farther from the sun than Earth is. That's way out there.
And even after the official end date, it kept talking to us.
Amazingly, yes. It continued to send back usable data for years. Its signal, though getting weaker and weaker, was actually used after 97 for training. Helping new flight controllers at the Deep Space Network practice the tricky skill of locking onto a very faint signal from the outer solar system. Pioneer 10 became like a practice target.
Huh, that's brilliant. But eventually the signal did die out. When was the last contact?
The very last bit of actual data, the telemetry, was received on April 27, 2002. It was about 80.22 AU away then, got about 33 minutes worth of signal.
And the absolute final whisper.
That came a bit later, January 23, 2003. A very, very faint carrier signal was detected. No data, just confirmation it was still faintly transmitting. It was about 12 billion kilometers away then, still around 80 AU.
7.5 billion miles.
Yeah. After that, subsequent attempts to listen just heard silence. The signal was too weak. They made a final official attempt to hail it on March 4th, 2006. No response.
And the cause was just old age and distance?
Pretty much. The RTGs were producing less and less power over time, as expected. Combine that with the ever-increasing distance, the signal just faded below our ability to detect it from Earth.
So now, it's just sailing on in silence. A ghost ship, as the sources
Exactly. Continuing its journey through interstellar space, completely quiet.
Which brings up the obvious question. Where's it going? Does it have, like, a destination star?
Well, it's heading in a specific direction. Its trajectory is pointed generally towards the star Aldebaran.
Aldebaran. That's the bright orange eye of Taurus the Bull, right?
That's the one. It's about 68 light years away.
And Pioneer 10 is traveling at what speed now?
Around 2.6 AU per year, which just sounds fast, but space is big, really big.
68 light years at 2.6 AU per year. Yeah, carry the one. That's going to take a while.
About 2 million years, give or take. And that's just to get into the vicinity of where Aldebaran is. Now, the star itself is moving too, so it's not like they're going to collide or anything.
2 million years. Okay. Mind-boggling timescale. What about Pioneer 11? Is it going the same way?
No, it's heading off in a different direction due to its Saturn flyby. Estimates vary a bit, but it's generally aimed towards the constellation Aquila, or maybe Sagittarius. Expected arrival time in that general direction, around 4 million years.
Even longer. And here's a key point from the sources, right? Neither Pioneer 10, nor 11, nor the Voyagers are actually going fast enough to leave the Milky Way galaxy.
Correct. They've achieved solar system escape velocity, but not galactic escape velocity. They're still bound by the galaxy's gravity.
So they're not truly leaving home in the biggest sense.
Nope. They'll essentially become tiny artificial objects orbiting the center of the Milky Way, just like the stars. They'll become, in effect, artificial star systems orbiting the galactic core for potentially billions of years.
Wow. Little pieces of human tech orbiting the galaxy forever. That's profound.
It really is. And the chances of them hitting anything are minuscule. Space is just incredibly empty.
Even nearby stars.
Yeah.
They've passed relatively close already, haven't they?
Yeah, within a few light years of stars like Proxima Centauri and Alpha Centauri, just by chance as they travel through the sun's neighborhood. But close in interstellar terms is still vastly far apart. No risk of collision.
Okay, so let's bring this back home. Why should this decades-long journey of a silent probe matter to you, listening right now?
Well, first off, it's history. It represents humanity's very first physical step out beyond the planets we knew into that truly unknown space between the stars. It was the first leap.
And the science it did. You mentioned the textbooks, the discoveries about Jupiter, navigating the asteroid belt that fundamentally changed how we saw our solar system. That's knowledge you probably encountered growing up.
Exactly. Pioneer 10 helped build that knowledge base. And then there's the plaque.
Yeah.
The whole story around it, the hope, the ambition, the arguments, it tells us so much about ourselves, doesn't it? Our deep desire to connect, to say we were here, and how incredibly difficult it is to figure out how to represent all of humanity to someone completely unknown.
And just the probe itself, lasting so long, doing its job, even helping train new engineers decades later. It's a real testament to human ingenuity, right? Pushing technology way beyond what anyone expected.
Absolutely. That persistence, that longevity, well, it's still out there, silently carrying on. A little ambassador from the 1970s.
So we've covered a lot. The launch, the first at the asteroid belt and Jupiter, the iconic, controversial plaque, and its long, silent journey onwards.
Yeah, an incredible voyage. And maybe here's a final thought, something stemming from all this. Pioneer 10 is now effectively its own tiny system orbiting the galaxy.
An artificial star system.
Yeah, a silent monument to human curiosity, carrying that message from decades ago. It'll keep orbiting for millions, maybe billions of years.
So the question hangs there, doesn't it?
Mm-hmm.
Will anything, anyone, ever find that plaque? And beyond that, what does this incredibly long, lonely journey really say about our place in the cosmos? About our first attempt to reach out? Makes you think.